Factoring, factoring, factoring. Now, I mentioned in the previous video that there's 6 types of factoring that we're going to talk about, right? 2 of which we've already talked about. One of them is the first one was the GCF, and the second was the simple trinomial factoring, right? Now, we have 4 more factoring techniques still to go. The one we're going to talk about right now is the difference of squares. Now, if you don't know how to do the first 2 types of factoring, which is the GCF and simple trinomial factoring, for sure take a look at Series 3A, because all I'm going to do right now is just build up from that. There's going to be a little bit of repetition, a little bit of just a reminder of what certain things are, but it's mainly going to be basically building from what we had before. Okay? The difference of squares is the simplest type of factoring there is, but it's there's a lot of misconception with it. Okay, for me it was anyway when I first learned it. The most common way that I've seen it presented is a squared minus b squared, right? So you go, it's a squared minus b squared. It's basically the difference of squares. What it means is, if 2 things are subtracted from each other, you can factor them out in the following form. It comes out as, if you have anything, a squared minus b squared. We'll talk about this a little bit further, but it's mainly presented this way, okay? If you have a squared minus b squared, if you want to factor this out, basically meaning you want to break this up into things multiplied together. That's what factoring means. You're going to try to break something up that's got addition and subtraction to it, and you're going to have terms multiplying each other to give you the same thing, right? So if you want to break this thing into things multiplied together, what it turns out is a minus b brackets times a plus b. Now it doesn't make a difference if you write down a plus b times a minus b, as long as you're switching between the plus and negative, okay? Now, if you want to work this out to make sure that you end up getting this, when you FOIL this out, what happens is we just go this times this, this times this, this times this, this times this, right? So you FOIL it out, you multiply the thing through. So if you FOIL this out, a times a is a squared, so you're going to go a times b is a times b, so you got plus ab. Negative b times a is going to be negative ab. And negative b times positive b is going to be negative b squared, right? And what happens, what you have here now is a squared plus ab minus b squared. Well, ab minus ab is just going to be killing each other off. So in the end, you have a squared minus b squared. Right? And this gives you that back again. Now, this is just for the check, okay? If you're factoring this guy, I've seen some people do this. When, you give them a question, say, factor something like this, they end up factoring it and then FOIL it back out again and end up here, and they leave this as the final answer. That's not the final answer. If they say factor it, this is the final answer. Okay? For the longest time, when I first learned about this method, I thought it only worked for things that were perfect squares. Okay, that's not the case. This method works for any 2 things subtracted from each other. So if you have something minus something else, okay, to factor that, all you do, you say the square root of the first thing minus the square root of the second thing, all of it times the square root of the first thing plus the square root of the second thing. So the way you can think about it is a squared minus b squared is the square root of a squared minus the square root of b squared times the square root of a squared plus the square root of b squared. And square root of a squared is just a, square root of b squared is just b. Same thing over here, right? So that's why it equals, right? That's why it equals the square root of a squared minus the square root of b squared. That's why it equals a minus b times a plus b. Okay? Now, to make this clear, let's go do it with symbols, basically squares. We said that it's a squared minus b squared. And that is, again, for me, it was a misconception. The best way that I've learned to think about this, to remind myself that any two things subtracted from each other, you can factor them out into the square root of the first thing minus the square root of the second thing times the square root of the first thing plus the square root of the second thing. Okay, and the best way you can do it is just visually think of a square. That's what the difference of square means. There are two different types of squares. Okay, and squares in mathematics, we symbolize it as, right? If you have one square, and square in math, a lot of books I've seen the way what they do is square represents you being able to put anything you want in there. So you can put anything in here minus another thing. Right? Two boxes subtracted from each other, the difference of squares, right? Two things like that, if you get anything, and it could be a gigantic term here, okay? It could be another function here, and that could be a gigantic another function, right? You can still factor them. So you can take two sections of anything and factor them as I think I went ballistic on colors here. It looks a little confusing. But anyway, if you have two squares, they're different squares, different thing in here than it is in here. Because if they were exactly the same thing, that thing would just equal 0, right? If you simplified it, it would just equal 0. So if you have two different things subtracted from each other, it's the square root of the first thing minus the square root of the second thing times the square root of the first thing plus the square root of the second thing. And that's for anything. And there's a lot of questions I've seen for difference of squares where they're really gigantic, confusing equations or confusing expressions that they want factored. And a lot of people get stuck with them because they have a hard time grouping things together. Okay, and we'll do a few examples where we're grouping different things together. Okay, so let's just start off with some simple examples and continue it from there. And this method, two things subtracted from each other, you can factor them like this. Two things added together, you cannot factor them. Okay, so if you have a box plus a box, so if you have two boxes added together, you cannot factor this. Okay, and we'll talk about why this is when we start going into the equal sign. When we got an equation where this side says equals 0. Okay, which is what we're really going towards, right? Factoring is just a tool that we have to be able to solve equations, because equations is where we want to be. Those are models of something, or that's our way of calculating whatever it is that we want to calculate, right? So factoring, when it comes out to straight factoring, it's just one step for us to be able to solve equations and to get answers. And solving equations means finding our x-intercepts, right? As we talked about before multiple times, right? And all of that stuff we talked about in Series 3A, right? So right now, let's just go do a few examples of this, just to show how easy it is. And it is. This for sure, as far as I'm concerned, it's the easiest factoring technique there is. And for some reason, a lot of people get it wrong. Because I guess it's an assumption. For me, it was an assumption that when they said a squared minus b squared, they meant anything has to be a perfect square. Not true. Any two things subtracted from each other, you can factor thus. Okay?